welcome to the last video for this week. Except maybe for the weekend. I haven't decided yet. Alright. So just so you know, the values, this is the note that's important. The values on our table differ a little bit from the values that the man used in the video, so don't worry about that. Different tables have different estimates. They're off by a kilojoule or two. Don't worry about that. Okay, so this is our last lesson that is included in the quiz that we're gonna have sometime next week. I haven't decided yet. So we're gonna be doing basically what is called Thermo stoichiometry. You can make that word any. They couldn't. So Thermo stoichiometry. So stoichiometry using stoichiometry. Or using stoichiometry of relationships in thermochemistry. And we have our first example. Again, this is these are slides 17 through 19 on the PowerPoint we did on Monday. Not the new one that's been uploaded to this document. So, here is the first question. It says, you combust 10 grams with excess oxygen. Determine the heat released by the reaction. And they tell us the reaction up here, and they actually have calculated the delta H for us. So what we know is we have 10 grams of methane. And by now, hopefully I know, as soon as you have the grams of something, usually we want it to convert it to moles. And we do so by dividing by the molar mass. Because we know that I got the molar mass of methane, which is 16.042 grams of methane, is 1 mole. And that is something we did over the summer, is to convert grams to moles. You divide the grams by the molar mass. So now at this point, the grams cancel. And we know how many moles we have. And now we want to know the energy released. And we also know that if you have 1 mole of methane, because in the equation there's 1 mole of methane, you release 802 kilojoules of energy. So then you get your calculator out and do that math. So this math here would be 10 divided by 16 times 802. And it comes out with sig figs to be 500 kilojoules per mole. So again, here you're using the enthalpy or the delta H as a conversion factor. Okay, this one is almost exactly the same, except there's one slight difference that everyone always misses. Last year when I taught this, or 2 years ago when I taught this, everyone had trouble with this. So again, they give us 50 grams of water. It's still the same equation. So you have 50 grams of H2O over 1. And hopefully by now you memorized that the molar mass of water is 18.16 grams, and that's equal to 1 mole. Now, we need to multiply by the energy. But if you look at the equation, 1 mole of CO4 releases that much energy, but in the equation there's 2 moles of water. So here, 2 moles of water releases 802 kilojoules of energy. So when you cancel out all the units, the grams cancel, the moles cancel, and you're left with kilojoules. And when you do this math, you do 50 divided by 18.006 times 802 divided by 2, and you end up getting, with sig figs, if you round nicely, it's this without sig figs. But it's only 3 sig figs, so it ends up being this with sig figs. So this is the answer here, and this is the answer here. So, again, you're using the delta H as a conversion factor based on the moles in the equation. In this equation, if you combust 1 mole of CH4, you get negative 802 kilojoules per mole, but that will produce 2 moles of water. And and 2 moles of water will release that much energy. So we have one more question, so that's one thermostoke problem, where they give you the grams, you convert it to moles, and then you use the enthalpy as a conversion factor here and here, based on the delta H goes on top, so the delta H goes on top, and on the bottom goes the moles from the equation. So you're getting that from the equation. And this is when they start with grams, giving you grams. But they could ask it the other way around, where it says determine the amount of methane in grams that you would need to combust to produce 450 kilojoules of energy. So you always start with what they give you. They give you 450 kilojoules of energy over 1. And we know you want to get rid of kilojoules, and we want to convert it to moles. We know, based on the equation here, that 802 kilojoules is released per mole of methane. So we have 802 kilojoules per 1 mole of methane. So kilojoules cancel, and we're left with moles. And again, they want grams, and we need to cancel moles. And you should know that 1 mole, and then up here we can put the molar mass of methane, which we already figured out up here, which was 16.042. And if you do this math, it's 4,050 divided by 802 times 16.02. With sig figs, and you should check to see that you can math okay. AP button pressing is 801 grams. Notice that in this problem, when they started with the kilojoules, we flipped this conversion factor. Here, the energy was on top when they started with grams. Here, when they start with the energy is now on the bottom. So in the homework, there's going to be all sorts of practice questions. One's using Hess's law, one's using the heat of formation chart, and the other one's using the bond dissociation energy. And then also there's I think there's 2 questions of thermostoke. But this is the end. Finally, you watched, I think almost 30 minutes of video. So have a good day.